In response to cold exposure, we increase our heat production, leading to the idea that mild cold exposure can help increase metabolic rate and reduce the risk of obesity. But do you respond differently to cold if you are already obese? In today's episode, we'll explore a study comparing lean and obese men's responses to different air temperatures. Does the extra insulation from higher body fat reduce the heat production response to cold and thereby limit the amount of extra energy burned? The increasing rates of obesity in modern society is a multifaceted problem with serious personal health costs along with cost and stress on the health system. To reduce this trend in turn requires a multifaceted approach. One idea is to literally turn down the heat, with the theory that lower room temperatures will cause humans to increase heat production through either increases in shivering or increases in the metabolic heat generated by brown fat in our bodies. This idea works in theory and is interesting, but it comes with the question of whether different people respond to cold in the same way. Specifically, if you already have high body fat, does it alter the way you respond to cold compared to if you're lean? This was the main question in a very detailed and controlled 2019 study. 12 lean and 9 obese Caucasian males of about 21 and 39% body fat, respectively, were exposed for 5 hours a day over 13 days to room temperatures ranging from 16 to 31 degrees Celsius. This was done at a set time each morning for all trials and after fasting from midnight onwards. Testing was done in a controlled room where their true metabolic rate could be very accurately measured. At the same time, electrical activity of 4 different muscles were measured to quantify shivering activity. After a final day of exposure at each participant's coldest tolerable temperature, the amount of brown fat and activity in the body was measured. The participants actually stayed in the research center the entire 2+ weeks and were fed a standard diet and performed a standard 30 minutes of treadmill walking daily. The overall results suggest that lean and obese individuals had distinctly different thermoregulatory responses to cold exposure. On the left graph, we have fat mass on the horizontal axis, with the red dots showing the obese participants and the black dots the lean participants. The vertical axis shows the lowest air temperature before heat production started increasing. So we see that obese participants generally started relying on heat production only at a lower room air temperature compared to lean participants. The right graph shows what happens once heat production actually started. Here, lean participants sustained a higher increase in metabolic rate at 17% higher than baseline, while obese participants had only a 6% higher than baseline increase. What conclusions might we draw from this study? One of the other interesting findings, first off, is that heat production was not a case of either brown fat metabolism or shivering, but rather both tools are used in parallel by the body once it decides to increase heat production. The bigger question we started with was about the potential for cold therapy as a way to increase metabolic rate and potentially reduce the risk of obesity. From this study, it seems that this might be effective if you are not yet obese, but only marginally useful if you are already obese because you start raising your heat production only at colder temperatures and overall to a lesser degree. Keep in mind that this was about one single cold exposure, so we don't know what happens with chronic cold exposure. The study was also done while fasted, so we don't know what happens when cold exposure is combined with the extra heat generated after eating. Finally, females and a more diverse population should be studied due to the known thermoregulatory differences across sexes due to the menstrual cycle. Hopefully this video turns the heat up on your interest about environmental physiology. I'm Professor Stephen Chung, and I run the Environmental Ergonomics Lab in the Department of Kinesiology at Brock University. We post new videos on different topics in environmental physiology every Wednesday. Thanks for watching. We'll see you next time.